All right, we're going to look at the next section here. This is about analytic trig. This is basically how do we use trig functions and show different identities and work with them in different ways. And basically we're just going to drop back and use a lot of algebra here. So the question is, how do we use algebra in the context of working with trig functions? So for example, suppose I tell you x is not 0, and I've got this expression. What can I do? Well, since x is not 0, I can divide and everything is fine. I can factor out an x here. And now the numerator can be written like this. These two terms can cancel. And I'm just left with something like that. So when we work with trig functions, we're going to have the same kind of thing. So suppose I tell you that the sine of some angle is not 0. And I have an expression like this. So I can divide, no problem. I've got a sine here and a sine here. I can factor that out. Now these two things will cancel. And I just get sine of theta minus 1. And basically what we're doing here is no different than what we've been doing in the past. The only difference is that we're working with this function that we're going to have to be called sine. Okay? The only one other difference, though, is that we're going to have some identities. So of the identities, we're going to have the Pythagorean identity related to this. We have that version of the Pythagorean identity. We have identities like definitions of trig functions. For example, tangent. Okay? And the question that's going to come up is, under what circumstances do I use this versus this identity? And the answer is you just get a feel for it, you try different ones, and whichever one happens to work in the most straightforward way for you, that's the one you're going to use. And just like when we did things like this, we're going to find that in some circumstances there's different ways we can approach it, and you just use the one that works at the moment. Okay, so I'm going to do a couple things here. First thing I'm going to do is talk about how do you verify identities, and then we'll talk about how we use trig identities to substitute into other expressions to change the form. All right, so for example, suppose I ask you to verify that cosine of x times tan x equals sine of x. Now, how do we do this? Basically, the idea is we're going to take our expressions and try to reduce them as much as possible. Then we're going to try to do some algebra to try to change the way the expression looks. We're going to hope to reduce the expression down to an identity that is obviously true. Right? So this is not obviously true, and we're going to basically boil this down to something that looks like sine equals sine. That we can say is going to be true. Okay? And then we have to go back and check to make sure that the algebra steps that we took can work backwards so that we can go forward, we get a result that we all agree with, and if those algebra steps work backwards, then the identity itself is true. So in this particular case, I'm going to work with the left-hand side and the right-hand side. Okay, so for the right-hand side, there's really not much I can do with that. Right? I can't really reduce that any further. The left-hand side, though, is a little more complicated. So the question is, what can I do with the left-hand side? So the left-hand side looks like that expression. I'm going to rewrite my tangent. So a common trick here is to take things like tangents and cotangents, secants, and write everything in terms of sine and cosines. And then once I've done that, then try to see what I can cancel, and then try to use the Pythagorean identities if possible. So another way to write tangent is sine of x over cosine of x. And now note, this divided by this is going to cancel, and I'm just going to be left with sine of x. Okay, so my left-hand side, I can reduce that to sine of x. My right-hand side is also sine of x. So here I have sine of x equals sine of x, and this expression came from doing basically the algebra steps to simplify what these expressions look like. So if sine of x equals sine of x, then this has to be true. Cosine of x times sine over cosine is still sine, and therefore this is tangent, so this thing has to be true. Okay? Let's look at another example that's not quite so straightforward. In this next example, I'm going to have to do some algebra that involves both sides of the equation. Okay. So let's see, I'm going to have cosine of t over 1 plus sine of t. And I claim that that is the same thing as secant t minus tangent of t. Okay? So the question, is that true? So I've got my left-hand side, my right-hand side. Now the first thing that's getting in my way is this denominator on the left-hand side. So I'm going to try to get rid of this. So I'm going to assume that that's not 0. And if I want to get rid of this, I'm going to try to turn this into another expression, so hopefully I can get something that looks like cosine equals cosine, or something equally clear. So let me get rid of this denominator. It's a sine. Sorry. So multiply both sides by this denominator. Okay. And since I'm assuming that the denominator is not 0, that's fine. If I do that, this cancels with this. I get cosine of t. Okay, now I'm going to FOIL this out and basically just try to expand this all out, and then eventually I'm going to turn this into 1 over cosine, the sine over cosine, and see what cancels. So my first step is this is going to be secant times 1 plus secant times sine. So I'm distributing that from there to there. It's going to be minus tangent of t times 1 minus tangent of t times sine of t. Okay. Now let's see. So this left-hand side again, I can't do much with that. So I'm going to hope that all of this boils down to just being cosine. If everything on the right is equal to the cosine, I have cosine equals cosine, and then I can go from do my algebra steps backwards to get to that, which is going to imply that that's true. All right, so let's see. I'm going to put everything in terms of sines and cosines. Secant is 1 over cosine times 1. Again, secant is 1 over cosine. Tangent is sine divided by cosine. And I just said that tangent is sine divided by cosine, like so. Okay. First thing to notice, sine divided by cosine minus sine divided by cosine, those two things cancel to give me 0. So let me rewrite that. So that's going to be minus. Now I've got sine times sine over cosine. Now I've got common denominators. So I can rewrite that way. Now I've got 1 minus sine squared. I can now use my Pythagorean identity, which says that cosine of t squared plus sine of t squared equals 1. If I subtract sine of t from both sides, that becomes 1 minus sine of t squared. So this whole thing in the numerator is basically the same thing as cosine squared of t. So let's see, this becomes cosine of t squared divided by cosine of t. So cosine squared divided by cosine just gives me 1 cosine. So I get that. So what does it happen here? So on the left-hand side, notice, as I went from here to here to here, I did not change anything on the left-hand side. So that is always going to be the same. And I just said that cosine of t equals cosine of t. Right? That implies then that cosine squared over cosine is cosine, which means that this is true, this, this. Everything works backwards, so basically this original identity is going to be true. Okay? All right. Let's do one more example. And this next example is how do we use identities like this to transform an equation. We've seen that transforming equations can be a very powerful idea. And this kind of identity is going to be a very important way to do things. And this, what we're going to do is something called trig substitution. Okay, so what do we do under trig substitution? So I'm going to take this expression and I want to write this into a new expression so that there's no square root. So that sometimes that square root gets in the way, and I don't like to do that. I want to get rid of it. And so here's the thing. I'm going to focus on the inside of the square root. On the inside of the square root, what do I have? I've got 4 minus x squared. I can think of that as some number, in this case 2 squared, minus a variable squared. Okay. What I have over here, look what I have here is I've got a constant minus some variable squared. Okay. So what the deal is, I want this to end up looking like 1 minus sine of t squared. If I can do that, I know this is going to be cosine of t squared, and the square root of that is just going to be cosine. Okay. This does not look like this, and the unfortunate thing is there's a 4 there. Right, so these numbers are different. So here's what I'm going to do is I'm going to multiply everything by 4. So if I do that, what do I get? I get 4 minus 4 times sine of t squared. Let me write this now. Let me bring that into the side of the squared. So this expression is the same thing as 2 sine of t quantity squared. So this thing right here, I want to be the same thing as that. So what I'm going to do is I'm going to say so there's my x, and this thing I want to be the same. Let x equal 2 sine of t. And now I'm going to go back up to my original expression. Okay, so what I've done here is basically scratch work. I'm basically exploring the expression, figuring out what's going on. And I'm going to hope that this, when I plug this back in, I'm going to get just cosine of t somehow in a nice way. I may not. If I don't, I have to start over. Okay, so let's see. So what do I have? I've got the square root of 4 minus x squared. I'm saying x is that thing. So everywhere I see an x, I'm going to replace it with 2 times sine of t. I'm going to do some algebra here to straighten that up. It's going to be 4 minus 4 times sine of t squared. Notice I can factor out the 4. this expression right there is just cosine of t squared. And notice the square root of 4 is 2. The square root of cosine t squared, I got to be careful here. Right? If I take some number and I square it and then take the square root, I've got to get something positive by definition of what the square root is. Cosine could be negative. So I get the absolute value of cosine. Okay? So given an expression like this, if I want to get rid of the square root and work with it in a different way, I can make a clever substitution by taking advantage of this identity. And I play around here. I recognize the pattern that this looks like something minus a variable squared. So I start out with what I want, try to manipulate it, in this case multiply by 4 till I get something that mimics what I had originally. That tells me what my substitution is going to be. I put it in there, I work it out, do the algebra. Be very careful about this algebra because it can be tricky.